All right, so we're going to start talking about today how to prove two triangles congruent. Last class, we would have talked about when two figures are congruent. As a quick review of that, two figures are congruent when all the corresponding sides are congruent and all the corresponding angles are congruent. However, what we're going to talk about today is that with triangles, it's not quite like that. There are some shortcuts involved. Okay, so that's what we're getting into now, how to prove triangles congruent. And we'll jump right into it. Because of something called triangle rigidity, there are only so many ways you can make a triangle. If you're given three side lengths, say 3 inches, 2 inches, and 2.5 inches, there's only one way that you can make that triangle. So if you know that three sides are congruent to three sides of a triangle, that's enough to know that those two triangles are congruent. You don't need the corresponding angle measures. You don't need to check to see if the corresponding angles are going to be congruent. They're going to be automatically. So the first shortcut we have is if we can somehow find a way to show that the three sides of one triangle are congruent to three sides of another, then we can use the side-side-side congruence postulate to say that they're congruent, and abbreviated SSS. And everyone abbreviates it SSS, so no worries if you do. So for example, in a diagram, as we're getting in the habit of marking our pictures and our proofs, we will know that we are done proving that two triangles are congruent if all three sides of one are marked congruent to all three sides of another, like this. Now, side's a nice shortcut, but when we write our congruence statement, we are going to have to make sure that we're matching up our corresponding parts, and it's a little bit tough with sides, so you're going to have to be careful. But if I wanted to, I would talk about the fact that triangle ABC is congruent to, and if I go AB, then I have to go FE, and then G would have to fall into place. So that AB and FE are congruent, BC and EG are congruent, and AC and FG are congruent. So all of my corresponding sides have matched up, and the angles will have to fall into place. Okay, and we can say that these two triangles are congruent by the side-side-side congruence postulate. You don't have to say congruence postulate, you can just say side-side-side. Okay? Just remember that when we write our congruence statement, that order does matter. We have to watch out for that. All right, so this quick example here, this quick activity, we want to tell, number one, we want to make sure that the two triangles are congruent. But then it says, decide whether the congruent statement is true, explain your reasoning, and we'll work on how to explain your reasoning. That's a little bit of a tough part for some of us. Well, first off, at number one, the two triangles IHJ and KHJ are going to be congruent. And that's because we can use reflexive on this segment here, HJ, which serves as the third side for my two triangles. I love it when two triangles share sides because I can use reflexive and get a set of sides congruent automatically. Okay, so our triangles are congruent. Now we've got to check and make sure that our congruent statement is written correctly. So IH is congruent to JH in this picture, right? IH and JH, nope, no. So this order is not correct. So no, the congruent statement is not right. You can, to explain your reasoning, you can say something like, the congruent statement does not match up and that'd be enough. Okay. All right, number two, are the two triangles congruent? Yes, by reflexive we're going to get this guy. Now check to see if the congruent statement is okay. Is LP congruent to PL? The answer to that is yes. Is PS congruent to LN? The answer to that is yes. Is LS and PN, are those two congruent? The answer to that is yes. So yes, and you can say that the order is correct, or the congruent statement matches, something like that. All right, try 3 and 4. Are the congruent statements correct? Make sure that the triangles are congruent first. Stop the video, start it back up, and see how you do. Okay, number 3, no. Order is not maintained in the congruent statement. So the congruent statement's not right, but the two triangles are congruent. Now, we ought to go back and practice writing the congruent statement correct. So in number 3, this congruent statement's not correct. So instead of saying triangle ACE, it's congruent to triangle BDF. We should say that triangle ACE is congruent to, and we need to go BFD. If we go back up to number 1, we would want to say that triangle IHJ is congruent to triangle, well, KHJ. Okay? Now, number 4, yes, the two triangles are congruent because of the reflexive part here, and the congruent statement, the order is maintained, so we are good there. Okay? All right. Now, as far as going about proving using side, 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 well, we have two options. And the nice thing about side, side, side is that we have some ways of showing that side lengths are congruent. Sides are segments. And so really it's just a matter of showing that the lengths are the same. There are some geometry ways to do that, and there are some algebra ways to do that. The algebra way is to do what's called a coordinate proof. We're going to take our two triangles and put them in the coordinate plane so that the vertices can have coordinates, and we can start trying to use what we know about a coordinate plane to find those lengths. Now, the first thing we have to remember is the ruler postulate. The ruler postulate says that for a vertical or a horizontal segment, we don't have to use the distance formula. We can just count grid lines, basically, is what the ruler postulate allows us to do. So, for example, if I wanted to find the length of JK, right here, then I can just count the grid lines and pay attention to the fact that the grid lines are scaled by 2. So from K to J, I'd have to go 2 plus a half, so 2 plus 1 is 3. For JL, we'd have to go down 2, 4, 6. For RS, we need to go down 2 plus 1, which is 3. And then go 2, 4, 6, so RT is 6. Now for KL and TS, they're not vertical or horizontal, so we are going to have to use the distance formula. So LK, distance formula, which says subtract the x's and square that, subtract the y's and square that, and then add those and square root everything. So the x's for L and K are -3 and 0. The y's are -8 and -2. -3 minus 0 is -3. -3 squared is 9. -8 plus 2 is -6. -6 squared is 36. So we get 45. Reduce that down to the 3 square root of 5. And then TS. All right, the x's for T and S are 10 and 4. The y's for T and S are -3 and 0. 10 minus 4 is 6. 6 squared is 36. -3 minus 0 is -3. -3 squared is 9. So we get the square root of 45, which reduces down to 3 square root of 5. So now we have shown that this side is congruent to this side, this one's congruent to this side, and now these guys are congruent. So by SSS, they are indeed congruent. Okay? Now we can do a coordinate proof, or we can do a two-column proof. Two-column proof requires us to use more of our geometry, definitions, theorems, postulates, things of that nature. Now, to do a two-column proof, here's the deal. We want to mark our picture. We keep showing you diagrams with all of these theorems and postulates, because that lets us know that if we're in the habit of marking our pictures, then the picture will let us know when we have enough information to say that our two triangles are congruent. So in this particular proof, we want to prove that triangle ABC and triangle ADC are congruent. All right, well, the thing is, you can't mark your picture until you've said that the pieces are congruent in your proof. So we always start with the given. So I'm going to go ahead and write all of my givens on this one line. As long as two statements are using the same reason, you can always combine those statements. And so since I'm using since I'm using given as my reason here for both givens, I can go ahead and put them in there at the same time. Sometimes you'll see the givens split up, and you'll see that actually in the notes today, both where the givens are together and when they're split up. All right, so since AB is congruent to CD in my proof now, I can go mark my picture. And then BC and DA are congruent, and I can go mark my picture there. So that's all I've got. So I can look at the picture and realize that I don't have enough information yet. I need to have three sides congruent to three sides. So I start working. Well, I realize that two triangles are sharing a side, and I love it when they share a side because I can do reflexive on that shared side and get a free congruent part. Right? And now that I said that AC is congruent to itself, I can go mark that in a picture like this. Okay. Now, I look at my picture. I've got three sides marked congruent to three sides. And we've been talking about how that with that shortcut, side, 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 that's enough. We don't have to have the angles marked congruent. So I can go ahead and say that the triangle ABC is congruent to triangle CDA. By side, side, side. And we're done. We've just proven the two triangles are congruent. Okay? All right, now, next example of a proof here, we've stripped away the statements, but we've left the reasons. And you may find this is a bit easier just because it does provide some direction on where to go in your proof. Okay? So take a second, stop the video, try to fill in your statements, and then you can start the video back up and see if what you've done is correct. All right, so they want you to put your two givens in here in separate statements, but all in here at one time. So right at the beginning here. So we have our congruent segments, and we've got that Z is the midpoint of WY. So WX, YX are congruent, and Z is the midpoint of WY. Now the next reason wants you to use the definition of a midpoint. Remember, the definition of a midpoint is a point that is in the middle of a segment. So if it's in the middle of the second segment, it basically creates two congruent segments. And the two congruent segments that we get are WZ and ZY. And since I've set it in my proof, I can go mark it in my picture. WZ and ZY are congruent. Now, we don't have enough information yet. We've only got two sets of sides marked congruent. So we looked at and see that that the two triangles are sharing a side. And the next reason is reflexive. And so we want to go ahead and do reflexive on that last remaining side, the shared segment there. I love it when triangles share sides. Now I can go mark my picture. I have enough information now. I've got side, side, side. So we're going to say WXZ, triangle WXZ is congruent to triangle YXZ, and making sure that we are matching up our corresponding sides. Okay? And we're done. So hopefully not too bad there. Now, there are other shortcuts besides side, side, side. If I gave you two side lengths and an angle measure, there would be only one way to make that. As long as that angle is in between the two side lengths that I give you, then there would only be one way to make that triangle, and so that would be enough information. Two sides congruent to two sides, and the angles in between them are congruent, those three parts would be enough to say that the two triangles are congruent. And then the other shortcut, hypotenuse leg. Hypotenuse leg, the only types of triangles that have hypotenuses are right triangles, and so it would make sense that hypotenuse leg is a shortcut that we can only use with right triangles. Okay? So let's get into it. First of all, this idea of an angle being in between two sides of a triangle, right? And what that is called an included angle. An included angle is an angle that sits between two sides of a triangle, two given sides of a triangle. So we need to make sure that we're picking out the right angles to prove are congruent if we want to use our shortcut that we saw there, SAS. Okay? So if my two side lengths that I'm working with are AB and BC, then the included angle would be the angle in between those two sides, or the angle created by those two segments. And that angle is angle ABC. The included angle for BC and CD is just angle C, or angle BCD if you want, either one. The included angle for AB and BD, here, the angle created by those two segments is angle ABD. Okay? Make sense? Think you got it? Go ahead and try the next three. Stop the video, start it back up, make sure you can pick out an included angle. Okay, and there are the last three. Any issues getting those? If it's not making any sense, make sure you come find me. Okay? Now, a quick review of a right triangle. Remember that right triangles have legs. They have legs, right? When the legs are the two sides surrounding the right angle. And then it has a hypotenuse, and the hypotenuse is always that side that's across or opposite of the right angle. Okay? And remember that we have to be able to pick those sides out, especially next semester. So we have to remember that the hypotenuse is definitely across from the right angle. Okay? Now, our next two shortcuts. Oops, sorry. Our next two shortcuts. First one's hypotenuse leg. Hypotenuse leg says that the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. What that would look like when you're done marking a picture, it would not be this. You wouldn't need these guys. Okay? You would just need the hypotenuses marked congruent and a leg. Okay, so there are the rest of the included angles there. Okay, if you're not able to pick those out, make sure you come find me. All right, quick reminder of parts of a right triangle. Okay, the sides around the right angle are legs. The side across from the right angle is the hypotenuse. We've discussed this before. Now, if we're going to use hypotenuse leg, then hypotenuse leg says that you would need to have the hypotenuses and a set of legs marked congruent in right triangles. So you would have to acknowledge the fact that you have right angles in your triangles so that we can acknowledge that we have right triangles. You don't have to say that they're congruent, but you'd have to say that they're there. And then you have to show the hypotenuses in one set of legs are congruent, and then you'd have hypotenuse leg. And so when you wrote your congruent statement, you'd want to make sure that you match up the right angles, and then, again, match up the sides that are marked congruent. Okay, so these two triangles are congruent by HL. Side angle side, the same thing, right? You will know, you need to recognize that you can use the side angle side shortcut if you've got two sets of sides marked congruent, and then the angle between them, that's your included angle, the angle between them is marked congruent to each other, then you can use side angle side. So in here, we can use side angle side, and we can say that the two triangles, ABC and FED, again, making sure that you match up the order there, are congruent by side angle side. And you can just abbreviate SAS as a reason. Okay? All right. Here we go. Decide if there's enough information to make these triangles congruent, and if so, state the postulate or the theorem. All right, well, in the first two, triangle ABC and DEF, make sure that you know which two triangles you're looking at, here and here, and is there enough information? Well, we've got two sets of sides. They're not right triangles, so we can't use hypotenuse leg. But we do have the included angle between them. So yes, there's enough information to make these triangles congruent, and the shortcut we would use would be side angle side, SAS. Number two, there are right angles, so there's a hypotenuse leg alert. We have two right triangles. So are the hypotenuses and the legs congruent? Well, the hypotenuses are here. And again, I love it when triangles share sides, because by reflexive, that guy can be congruent to itself, or is congruent to itself. And so now we have a set of legs marked congruent. So yes, these two triangles are congruent, and they're congruent by hypotenuse leg. Now, keep in mind that even in right triangles, we can use the other shortcuts. We can use side angle side, because those right angles are actually congruent, and we'll see one of those in just a second. But if you're going to use side angle side in a right triangle, you would have to say that those right angles were congruent. So you have to be careful there. Okay? And number three, do we have any of our shortcuts? Three sides to three sides? No. Two sides and an angle. Well, we've got two sides that are marked congruent to each other here, but they do not have, they are not marked congruent to their corresponding sides over there. So this is no, this is not side angle side. Okay? All right. Couple of proofs. Let's go look at these two proofs and then turn you loose on your homework. Okay? All right. So I want to prove triangle OML is congruent to triangle OMN. And I can pick those two triangles out pretty easily. They're here and here. And so I want to go to work. Now, some statements and reasons are mixed in as far as what you've been given and what you have to go find. So let's see if we can't follow the thought process here. First statement's always a given, and it was only the first part of the given, the fact that OM and LN are perpendicular. If it were me, right now, there's another given statement, ML and MN are congruent. I would go find that, and that's right here. So I can use given in here as our reason. And since I found it, I'm going to go ahead and mark the picture, so ML and MN. And then I'm going to go back up and start filling in the other stuff. So since OM and LN are perpendicular, we have to remember that perpendicular lines form right angles. So I can say that angle OML and angle OMN are right angles. Okay? And that's by, not all of this, this is just by the definition of perpendicular lines. Okay? You don't have to write the definition out. Definition of perpendicular lines. Now, this proof wants you to go ahead and use the fact that right angles are congruent to say that those right angles are congruent. Now, we don't have the hypotenuses marked congruent, so this is probably not a bad idea. Remember I said if you're going to use HL, you wouldn't have to say that these angles are congruent. But since we don't have the hypotenuses marked congruent, we ought to go ahead and say that our two right angles are congruent, because all right angles are congruent. And then I can make my box in here for OML and understand that the box now is a congruent symbol. Okay? All right. I love it when two triangles share sides, because I get a free congruent part. OM is congruent to OM by reflexive. Right? Go mark that in your picture. And now we have not hypotenuse leg. The hypotenuses, which are here and here, have not been marked congruent. Instead, we've got our two sets of legs, and the right angle is in between them, and we said that the right angles are congruent. So instead of using the hypotenuse leg, we're using side angle side. Okay? So make sure that you keep that in mind. All right. We've got another proof here. Take a couple of seconds and see if you can't fill in the missing lines. And then start the video back up, and I'll let you know if you're right. Okay. So, B is the midpoint of AE. That's given. Now, B is the midpoint of CD is also given. So I'm going to go find that statement and fill that in with given also. Now, B is the midpoint of AE is not a congruent statement. It doesn't tell me that two things are congruent, so I can't mark my picture. But I do know that if B is the midpoint of AE, if B is the midpoint of AE, then it does create two congruent segments, which are AB and BE. That's by the definition of midpoint, as you see there. So I can get in here and mark these guys congruent, AB and BE. Now, because B is also the midpoint of CD, I can do the same thing over there and say that BD is congruent to BC. And that, again, is by the definition of midpoint. And so I can go mark my picture. BD and BC are congruent. Okay? Now, the next statement suggests that angle ABD and angle EBC are congruent. Why? Well, hopefully you realize that these two angles, you remember, are vertical. And vertical angles are always congruent. And so we can say that vertical angles are congruent. Vertical angles congruence theorem. So now we said those angles are congruent, we can go mark our picture, and we now have three parts. And we've got two sets of sides that are marked congruent and an angle between them. So we can use side angle side to prove these two triangles are congruent. Okay? So there you go, a couple of proofs there. Go ahead and get started on your homework. Have that done by next time, and we'll make sure to go over it.